Today we will be talking about square root functions. Let's analyze the basic function y equals the square root of x. What values could you plug in for x that would give you real solutions? What values would you plug in that would give you imaginary solutions? I want you to list 3 values below for each. In order to get a real solution, I could plug in the value x equals 4. If I plugged 4 into my function, I would get y equals positive or negative 2. Another value I could plug in is x equals 6. If I plug in x equals 6, I may not get a whole number, however, it'll still be a positive value under the square root. Another way I could look at this is to get a real solution, I would have to have whatever's under the square root to be a positive number. So therefore, if I plugged in any positive number in for x, I would get a real solution. Another way I can say this is x is greater than or equal to 0. If x is 0, it's still a real solution. When we talk about imaginary solutions, we talk about when there is a negative under the square root. So a negative 6 or a negative 8. Any negative number will fulfill the imaginary solution. Another way we could write this is x is less than 0. It has to be negative. And more specifically, whatever's under the square root has to be less than 0. At this point, we're going to graph that same function. So go ahead and take your graphing calculator and plug in y equals the square root of x and graph the function below. This is probably what your graphing calculator gave you. I want to also point out that there's more to the graph than just what your graphing calculator gave you. If we plugged 4 into this, we would get y equals the square root of 4. If we take the square root of 4, the square root of 4 can be positive or negative 2. So essentially, this graph can also be down here to complete the graph. I want you to take a second and explain why the graph looks the way it does. Why are there certain x values? Why are there certain y values? Go ahead and hit pause and do so now. I'm first going to look at x values. We know that x values have to be greater than 0 because on the last slide, in order to have real solutions, what was under the square root had to be greater than or equal to 0. That tells us 0 is our first point that we're going to make, and that was right here. That tells us that the domain, the list of x values, starts at 0 and goes to the right on your number line. Now let's look at the y. The y values can be positive or they can be negative because of the square root. You know that when you find the square root of 4, it yields a positive, negative 2. So anytime we have a square root, we can say there's a positive and negative sign out front of it. So that gives us the range. We would say that the range here for y values would be all real numbers. That's just a basic graph of the most basic square root function. Now we're going to take a look at a couple more that are a little bit more challenging. In this example, we're going to use the same concepts as we did from the basic one. I want you to go ahead and plug this into your graphing calculator at this point and sketch the graph. This is what the graphing calculator pulls up. I want to quickly point out that when you plug this into the graphing calculator, it restricts the range to only positive numbers, so only y values are positive. What this is telling you is that you're taking the principal square root. So if they give you a function that has a square root in it already, then we don't include the negative version. But the one thing that we have to keep in mind is if we take a square root of a function, so say we have a function y squared equals x plus 2, and we took the square root of both sides, then we would have the positive, negative version. But in these cases, when they just give you y equals the square root of something, we're just looking at the positive version. So keep that in mind. Although we know that this could go down here as well, we're just going to take the positive version. What x values can you plug in that will give real solutions? We call this the domain. You know from previous lessons that anytime we have a square root, whatever's in the square root has to be greater than or equal to 0 in order to form a real solution. We cannot have negatives under the square root. So what we do is we take what's under the square root and we say it has to be greater than or equal to 0. If we subtract 4 from both sides, then we say the domain, or the x values that we can plug in that give real solutions, have to be greater than or equal to negative 4. And what y values can you plug in? So what is the range? Looking at the graph, you can tell that the range is positive. They're all positive numbers. Remember, we're just looking at the positive version of this square root. So we would say y is greater than or equal to 0. It can be equal to it. It is right here. And it all goes positive. As a general rule, we can say that our domain, or the possible x values that we can plug in, is dictated by what is under the square root. And what we do is we take that value, whatever it might be that's under the square root, and we put it greater than or equal to 0, and we solve it out to find what x values we can plug in that will give a positive number under the square root. And the range, the y values that are possible to come out, is dictated by what is outside the square root, what's added or subtracted. And the reason being is that y can only be certain numbers. The smallest number that this can be would be 0. So our smallest y value in this case would be 3. In the other examples that we looked at, there was nothing outside it, so we could essentially say it's plus 0. So the smallest number that y could be would be 0. So if the smallest y value is 0, we can say that the y value would be greater than or equal to 0. Everything is positive in this case. The last type of problem that we're going to do is a square root inequality. We're going to treat this nearly the exact same as we have any other inequality. We're going to graph the y equals function first, which in this case is y equals square root of 2x minus 6. So go ahead and graph this in your graphing calculator now and hit play whenever you're ready to go. These 2 points are definitely on the graph at exact coordinates, the coordinate 3, 0 and the coordinate 5, 2. From there, if we remember, our sign is just less than, so it must be a dotted line. The next thing we do want to list, especially if they ask us, is the domain and range. We can do this by looking at the graph. The domain is the x values, the range is the y values. So the domain is x is greater than 3. Notice when we drew this line, x could be equal to 3, but since it is a dotted line, it has to be strictly greater than 3. The range is positive. All y values are positive, so we say y is greater than 0. And the next thing we're going to do is we're going to do a test point that is not on this line. So I'm going to choose the test point 6, negative 1. Using this test point, I'm going to plug it into my original function using the x value of 6, the y value of negative 1, and see if it creates a true statement or a false statement. At this point, when I work this problem down, I get negative 1 is greater than the square root of 11. Although I don't know what the square root of 11 is off the top of my head, I do know that it's going to be greater than negative 1 because it will be positive. So this tells me it's a true statement. That means I'm going to shade with my test point. The one catch on these problems is that when you make the starting point, you want to make the line going down, and this is going to be your shaded area. And it's going to keep going on and on and on. Please check out the supplementary videos if needed.